In this lesson, we'll be working with radicals. And you definitely saw radicals last year when you were using the quadratic formula. But today, we're going to learn how to simplify expressions involving radicals. Okay? In order to do so, we need to learn a relationship that exists with radicals. So I wrote it down here. Root A times root B. Of course, A and B are both greater than or equal to 0. So if I have root A times root B, you can simplify that to root AB. Okay? Root A times root B is equal to root AB. I'm going to write that down here. But I really want to explain that to you. I want to prove that to you. I want to convince that that is correct. So in order to do so, we also have to understand that why is it this first transition here? I said that root A times root B can be rewritten as A to the power of 1/2 times B to the power of 1/2. So in essence, I'm saying root A is exactly the same as A raised to the power of 1/2. Okay, that is going to take some explaining. But once we understand why this is true, then it will make perfect sense that root A times root B is root of AB. All right, so let's do something that hopefully is pretty straightforward. So what's root 4? Okay, root 4 is equal to 2. So why is root 4 is equal to 2? Okay, you probably said in your mind, well, 2 times 2 is 4, so root 4 is equal to 2. Okay, let's keep the good vibes going. So, you know what, let's do one more. What's root 9? Root 9 is 3. Why is root 9 equal to 3? Because 3 times 3 is 9. So, what about root A? What's root A? You know what? I'm going to show you here, okay? A to the power of 1/2 times A to the power of 1/2 is equal to A. A raised to the power of 1/2 times A raised to the power of 1/2 is equal to A. And that makes perfect sense because we learned in grade 9 when you multiply two powers at the same base, you add the exponents. Well, what's half plus half? Half plus half is 1. So I guess you can mark the invisible exponent there of 1. But if you can accept that this is true, which it is because half plus half is equal to 1. So that means if I multiply A raised to the power of 1/2 by itself, I'm going to get A. Just like how when I multiply 2 by itself, I get 4. When I multiply 3 by itself, I get 9. When I multiply A raised to the power of 1/2 by itself, I get A. So guess what? Root A is equal to A raised to the power of 1/2. So that is beautiful because now that this hopefully makes sense, this transition, this second line makes sense. And from grade 9, we also learned that you can express this as all of AB raised to the power of 1/2. And since raising something to the power of 1/2 is exactly the same as square rooting, we can conclude that this is ultimately root of AB. So root A times root B is exactly the same as root of AB. So the most important thing to understand here is that having an exponent of 1/2 is exactly the same as square rooting. All right, so now we need to learn some terminology here. So what we have here is called an entire radical. Okay, the number under the radical or the expression under the radical, that's called your radicand. Now, if possible, we want to express the radical as a mixed radical. Okay, so this is considered to be in simplified form, and we are going to learn how to convert it into from an entire radical to a mixed radical. Okay, if possible. It's not always possible to make that transition, but if it is possible, we prefer to express it as a mixed radical. All right, so how do we go from an entire radical to a mixed radical? So I showed you the first example, root 50. I'm going to try to express this as a mixed radical. So I broke apart 50 as 25 times 2 because 50 is the product of 25 and 2. Now, why would I break down 50 into 25 times 2? Because 25 is a perfect square. And that is beautiful because remember we just said earlier, root of AB is equal to root A times root B. So I express it as root of 25 times root 2. But like I said, root 25 is a perfect square, so root 25 is just 5. So 5 root 2, perfect. So root 50 is exactly the same as 5 root 2. And if you're allowed to have a calculator on the test, you can check root 50, 5 root 2. So you're very confident that's correct. Okay, so we chose 25 and 2 instead of, and not like 5 times 10, because we need a factor that is a perfect square. Okay, so let's see. 27. Okay, root of 27. Can we simplify that to a mixed radical? 100%. Because 27 has a factor which is a perfect square. Which is that one? 9. So root 27, okay, root of AB, root A, root B. So root 9 times root 3. Root 9 is, of course, I just said it, perfect square. So instead of root 9, I'm not going to write root 9 anymore. Just write 3. So root 27 is exactly the same as 3 root 3. All right, what about root of 180? All right, now you don't work with 180 as often, but 180 has a very okay. So for the next example, you have root of 180, and we want to simplify that. So I know you don't work with 180 very often, but you just have to think about the perfect squares, the factors which are perfect squares. Now, if you don't know, then you can just play around and take 180 and divide it by perfect squares. Like, oh, hey, let's see if 9 is a factor. Or see if 16 is a factor, because 16 is a perfect square. Let's see if 25 is a factor, and so forth and so on. You could usually hopefully do these questions in your head, but if you can't, then use your calculator. So 9 was a perfect square, a factor which is a perfect square, but 36 is better. 36 is a greater perfect square factor. So if you use 9, you have to do 2 steps in order to simplify. If you choose to work with 36, you'll do it in 1 step. So let me show you what I mean. So let's say you thought of 36. If you thought of 36, bam, okay, 6 root 5. Now, if you didn't think of 36, let's say you thought of 9 first. So root 180 is root 9 times root 20, which is 3 root 20. But if you left it as that, you're wrong, because a radicand of 20, you can keep going, because 20 has a perfect square factor of 4. So you can keep breaking it apart. You can keep simplifying. So anyways, root 4 is 2, so 3 times 2 will still get you your 6. So always check your radicand. If you can find another perfect square factor, you have to keep going. Okay, so now that we are able to simplify radicals, entire radical into a mixed radical, we can apply our operations here. We can add and subtract, for example, but as long as the radicands are the same, because if the radicands are the same, then we have like radicals, just like what you learned before in grade 9, like terms. Like if root 2 here is x, it makes sense that 7 root 2 plus 2 root 2 is 9 root 2. It's the exact same logic. Like if I had 7x plus 2y, you wouldn't say 9xy. Okay, you can only collect the terms if the terms are like. You can only collect the radicals if the radicals are like. So same logic here. If 7x minus 2x is 5x, then 7 root 2 minus 2 root 2 is 5 root 2. All right. Yeah, of course. So we can't simplify this, so leave that alone. All right, 9 root 7 plus 2 root 7. Nice. 11 root 7. 4 root 3 minus 2 root 27. Wait a minute. 27 Even though they don't seem like they're like radicals right now, let's check. Let's investigate, because root 27 is, well, 27 is 9 times 3. So wait a minute. Something seems fishy here. So root 9 is 3. So 2 times 3 is 6. So this is really 4 root 3 minus 6 root 3. And 4 root, oh, they are like radicals. So anyways, negative 2 root 3. Okay. Let's multiply here. So 2 root 3 times 3 root 6. I'm going to do this the long way, just to help you visualize what's going on. So this is really 2 times root 3 times root 6. So I'm going to, since it's multiplication, I can reorganize it, because multiplication is commutative. So I'm going to write it as 2 times 3 times root 6. So I put the radicals beside each other and the numbers beside each other, the whole numbers. So 2 times 3 is 6, and root 3 times root 6, well, that's root a times root b, which is root of ab. And 18, can I simplify that? 100%, because 18 is 9 and 2. So root 9, that's 3, so 3 times 6 is 18. Bam. When in doubt, check with our calculator. So we have 2 root 3 times 3 root 6, 18 root 2. Bam, 25.4 something in both cases. Feeling good. All right, so now, just like before, we're going to distribute this. So 2 root 3 times 4, that's going to be 8 root 3. And here will be minus 10 root 9. Well, root 3 times root 3, hopefully you can see that's equal to 3, but I'm going to write root 9 just to extra step. So 8 root 3, root 9 is 3, so 10 times 3 is 30. Beautiful. Can I keep going? No. So just leave it alone. It's beautiful as it is. All right. Squaring 3 root 5 minus 4 root 2. So there's a simpler way to do this. It's just perfect square trinomial. So a minus b all squared is a squared minus 2ab plus b squared. All right. So 3 root 5, so that's 9 times 5. So 2 times 3 is 6, 6 times 4 is 24, root 10. So square the 4, square the root 2, right? Because this is ab all squared is a squared times b squared, or a squared b squared. So 16 times 2, so that's 45, and that's 32. I'll just write it down. Before I keep going, root 10 as a radicand, I can't simplify because there's no perfect square factor. Well, there's one, but we ignore one. One isn't going to get us anywhere. So 45 and 32 is 77. All right. So once you're very comfortable with simplifying radicals, like going from an entire to a mix, then you can add and subtract, multiply. But it all comes from the fact that root AB is equal to root A times root B.